Thank you so much. Good afternoon, everyone. With this presentation, I will give you an overview of main 3D functionalities in geOrchestra, as well as related MapStore features and some data processing gains we have developed during last month, and ongoing work on this. This morning we have seen new entries concerning MapStore functionalities and new capabilities for the 3D, saying what is present already in MapStore 2 geOrchestra, and as far as 3D functionalities are concerned, I think it is quite important to to better highlight this, to properly provide indication on what is effectively present in MapStore 2 geOrchestra in terms of 3D functionalities. So first of all, we should mention which kind of 3D data format are supported in MapStore 2 geOrchestra. For sure, 3D tiles is the main 3D format supported in the MapStore 3D mode, as well as 3D GLTF and GLB models that can be managed as external graphics in a dedicated 3D model symbolizer for the Visual Style Editor. Concerning 3D tiles, we have the possibility to, and the related layer settings for managing point clouds, of course, or batched 3D models or instanced 3D models. One of the most important tools present in geOrchestra concerning the 3D is the Views tools. That is a tool, that is a really powerful tool that allows you to provide to end users an immersive experience by configuring different views. The user can navigate together with a descriptive section on the site to indicate which is the purpose of the view and what the user is seeing. With lots of functionalities, configuration functionalities that are available for views in terms of which are layers visible for a certain view that must be visible for a certain view, which kind of camera orientation and position a certain view can have, as well as the description and other functionalities and configuration properties specific for the 3D mode, like the globe translucency and the ability to clip and mask 3D tiles and terrain layers to enrich your visualization purposes, especially when you want to combine different data. Maybe you want, for example, to clip a terrain or a 3D tile, to put for example, a model of a new building in the middle, and enrich the visualization of this for your specific purposes of your project or inside the view. Just a second. The measurement tool is another important tool we have developed for the 3D, providing advanced 3D measurement capabilities in the 3D. There is also in the last in 2020, 2023, if I remember well, a new UI has been introduced, more compact and performant for the measurement tool, for which we have different kind of measurements available, like distance, areas, you can see, point coordinates, but also specific for the 3D, aid from terrain, angle, slope, all kind of measurements that are really useful for the urban planning. Concerning the styling properties, We have already mentioned something this morning. We have also specific symbolizers for vector features with specific properties for the 3D. We have mentioned some of them this morning, but we have, as you can see from the slide, we have the clamp to ground reference. We have the bring to front property to effectively be able to visualize certain feature, considering also possible obstacle, 3D obstacle, due to other 3D features that are in the middle. And the other specific 3D model symbolizer that I mentioned before to support GLTF and GLB models. The clamp to ground functionalities for the styling is effectively useful also when you want, for example, to combine 2D data in a 3D environment, okay? Just to see how they are positioned and placed over the terrain. Another important feature is the ability to configure and see terrain layers in the 3D environment, okay? Where you can configure, we have provided the possibility to configure different types of terrains so that you can have a terrain based on a WMS provider, for example, from your GeoServer, or having it based on the standard cesium provider. For this, during the last year, we have also worked on providing quantized meshes support for terrains in MapStore. So with the aim to improve basically to make it more performing, I mean, in general. And in the latest major release, we have also, so not in geOrchestra at the moment, we have also split it into the concepts between terrains and elevation, okay, so that you can have different configurations for visualization purposes and elevation purposes when you, for example, move the mouse over the terrain to see the elevation value. Layer settings host specific functionalities for 3D tiles, especially for point clouds, so that we have included a way for making the point cloud more uniform for visualization purposes, okay, and more performing, so that you can manage the attenuation, the contrast, the lightening, and things like that. You can see some, I don't know if you can see better than this, the results, but you can try directly on MapStore to geOrchestra. Yeah, general 3D map configuration options are available, so that you can, of course, manage, yes, the atmosphere, ground atmosphere, sky atmosphere, but the most important is the enable depth test against terrain, which allows you to well configure, I mean, well see how your features are positioned in the 3D, if they are under or above terrain, and things like that. The 3D support, as I probably already mentioned this morning, is available also. 3D maps precisely are available also for GeoStories and dashboards. So let's jump into the digital twin toolbox slides. That is a product on which we have worked during the last year, basically, where effectively leads on the need where consuming 3D data in WebJS application effectively become increasingly a requirement, no, over the last year. So for many organizations, there are many range of uses. For example, the digital twin, the urban planning, for example, but also the aerospace, undersea and underwater contexts and things like that. So in the overall picture, the 3D tiles format become one of the most common OGC standards for streaming and rendering 3D geospatial content. Sorry. And so here we can have things like LiDAR derived meshes, 3D building, point clouds we have mentioned, and so on. So in response to these ever-growing needs, public administrations, private administrations have in this context, where they have usually to have they start having concrete needs of having a good and reliable 3D representation of their data, and where they usually need to combine also 2D informations in a 3D environment in a reliable and stable way, considering the terrain, buildings, and so on. So in this context, it is quite usual. Two main things are quite usual. Normal needs are identify best tools for viewing 3D data in a 3D tiles format. Of course, the answer for this is immediate. You can use MapStore, okay? And last but not the least, identify tools for converting data sets into 3D tile formats in a correct and performing way. So the real challenge here is how I can do this using open source tools. So the digital twin toolbox is what we are developing and what we have developed, and we are still working on for this purpose. So its aim is to basically completely support with the process of with the conversion processes to 3D tiles, of course, especially for inspecting, assessing data sets, and providing the possibility to classify them, process them, okay, like for example to translate them, colorize them, resample them, manage the geometric error for detailing, for visualization purposes, and for making your 3D tiles performing, and so on, but also to manage geospatial representation, the georeferencing stuff, georeferencing tuning, the coordinate reference system, but most important, the vertical datum. That is what is really important, especially for a good representation in the cesium that is based on the WGS84 ellipsoid. So the main objectives of this tool is to effectively provide the best open source tool for processing common data sources, for the moment shapefile and LAS files. More formats will be supported in the future. Focused on the urban environment. So provide a bunch of processing chains and workflows, but also methodologies to, as I said, inspect, evaluate, prepare, process data, convert them, preview them, and all of this through a user-friendly UI in a Dockerized environment. So the digital twin toolbox user interface is organized in three main areas. The control panel on the right, which provides you a set of, depending on the input format, of course, and the type of conversion you are trying to do, or from shapefile or from LAS file, for example. So depending on the initial setup, that you can still control there, you have basically a set of configuration properties of parameters that you can tune and use for the process of inspecting and previewing and manipulating, your data for the conversion. The area in the middle provides you an overview of what you are doing when you manipulate these parameters, of course. And so there is a preview purpose. That's for preview purpose, as I said. And the other panel on the left provides you a log of the operations performed by the digital twin toolbox. The preview of the final result for the conversion to 3D tiles can be seen directly on the main interface. There is a preview tool that can be opened, but there is also in the Docker an embedded MapStore that you can load and use for previewing the final result of your conversion, maybe including also the terrain, okay, so that you can also see how the data you have prepared, you have generated is combines basically with the terrain. So there are, this is a slide representing, I mean, the available flows. Each flow has a specific tool for its purposes. I mean, so from top to bottom, as you can see, a specific workflow for conversions of polygons, line, points. Okay, then for the processing through pedal of the CRS, the colorizations of point clouds, resampling and stuff like that, and specific processes and workflows for the direct conversions to 3D tiles, including tiling parameters and tuning and other properties mostly connected to 3D tiles, like the geometric errors and things like that. And we have also an experimental process for generating meshes from point clouds. These are a few examples from the municipality of Florence, where we have worked for generating indeed 3D tiles. As you can see here, all these data are coming directly from the urban environment, okay, with the aim to provide a digital twin representation of the city. Here we have, for example, for the point layer, we have, what happens?
Low battery.
So here, for example, we have used an instanced model for representing trees, okay, and in the digital twin toolbox, that's something that you can parameterize. So, for example, it will be possible to choose the type of model of the tree you want, depending on the properties of the layer. If there is a property that allows you to identify a specific tree from another, and using a specific model for it. So that's another example. So for the future work, just the last two slides, we are working for enriching the current functionalities. So we are actively working on improving the classification capabilities for point clouds, still using open source tools. And next steps will be to include more advanced and complete support for photogrammetry processes, also for the generations of 3D meshes. Automate at least some kind of workflows to speed up with the process, and for improving performances, including also support for level of details, and improving a little bit the tiling system for really huge data. That's something for which we have in mind to do a final release this year. For the moment, we have the project available on GitHub. It is open, and we have already delivered a pre-release with the functions that I have shown now. But it is also important to mention there is a wiki page we are maintaining, including tutorials that you can follow. And we had a webinar last week focused on this, that you catch up on our YouTube channel. if you want to learn more on it and if you want to see it in action. Okay? Thank you so much.